Good morning, everyone. Today we are going to continue with cell membrane and how substances move across your cell membrane. Today we are starting with osmosis. Osmosis is the diffusion of water molecules through a partially permeable membrane or selectively permeable membrane. It is the movement of water molecules from an area of high concentration, an area where there is a lot, to an area of low concentration where there is less. What we have to learn now is osmosis in terms of water potential. So the concentration of water molecules that you have is the water potential. So it's now called water potential. So where you have an area of plenty water molecules is called a high water potential. And an area of low water molecules is a lower water potential. So osmosis, some of the water molecules, if you have distilled water, there are zero impurities. So it's 100% water molecules. However, when you add impurities like sugar or salt, it associates with the water molecules. So the salt or the sugar is dissolved by the water molecules. So some of your water molecules are occupied around the sugar molecule. So in the diagram, you would see that there are some water molecules associated with that impurity, which is the sugar molecule. And then there are free water molecules. So when we think about osmosis and the movement of the water, we are talking about the movement of free water molecules. So the free water molecules are the water molecules that are able to diffuse across the membrane. So the tendency of these water or free water molecules to move from an area of high concentration to an area of low concentration is osmosis. So osmosis is the diffusion of water from a region of high water potential to a region of low water potential through a partially permeable membrane. Water potential is measured in kilopascals, where the highest water potential is that 0 kilopascals, and that will be represented by a solution that have zero impurities, aka distilled water. Anytime we add impurities, it lowers the water potential and we get into a negative number. So the highest water potential would be 0. And as you add impurities, it is going to go down into the negative numbers. So when we add sugar or salt or other substances, it lowers the water potential, making it a negative number. So the more negative a number is, the more concentrated the solution will be. Okay, so we're moving on. Let's talk about osmosis and cells. So as this would be, you would be familiar with this before. So we have three types of solutions: hypertonic, isotonic, and hypotonic. When we think about a hypertonic solution, this solution has a lower water potential or is a very concentrated solution, right? And the water is going, and inside of the cell is going to have a higher water potential. So if inside of the cell has a high water potential and outside has a low water potential, the water is going to move from inside the cell where there is high water potential to outside the cell where there is low water potential. Initially, the cell loses water and it will become flaccid. But as the cytoplasm shrinks and pulls away from the cell wall, we say the cell has become plasmolized. If we move on to isotonic, isotonic means that the solution on the outside and the solution on the inside has the same water potential. So the water net movement is equal to going in and coming out of the cell. A hypotonic solution means that the water on the outside has a higher water potential than inside of the cells. Therefore, water is going to move from outside and move within the cell. The plant cell becomes full of water and it's said to be turgid. The cells become turgid. As the water moves within the cell, there becomes something called a hydrostatic pressure because the water filling up in the cell is going to put pressure inside of the cell. This is called hydrostatic pressure and it pushes on the cell. Because of the cellulose cell wall of plant cells, the plant cells do not burst from this hydrostatic pressure when waters enter. It just becomes turgid. So now we can say that water potential is equal to pressure potential created from the hydrostatic pressure as well as solute potential. Solute potential means the amount of solutes that exist within the solution of the two areas. So now that we have talked about osmosis in plant cells, now let's go on to osmosis and the movement of water in animal cells. So when we think about hypertonic solution for animal cells, outside is going to have a low water potential and inside of the cells has a higher water potential. So water is going to move from within your cells and go outside of your cells, a region of high water potential to a region of low water potential. The cell becomes wrinkled. An isotonic solution, there is equal water potential on the inside and outside, so the cells remain the same. And in hypotonic solution, outside will have a high water potential, and inside of the cells will have a lower water potential, and therefore water is going to move within your cells. However, if your cells remain in that solution too long because it does not have the cellulose cell wall, those cells are going to burst. So now we are moving on to active transport. Right, so active transport means that a substance can move against the concentration gradient and it can happen at a faster rate than diffusion. For this process to occur, it must have a form of energy. So active transport moves against a concentration gradient, meaning from a low concentration to a high concentration, and it requires ATP or energy for it to happen. It is considered a type of bulk transport. If you think about picking peas from a tree and you pick it in your hand, you could only collect a little bit in your hand. However, if you have a bag, you are able to move more of it or pick more of it and have more of the peas. So think about it. In bulk transport, you use vesicles to transport substances across. So you are able to transport a large amount across the membrane at a specific time. For example, when you have hormones in large quantities can be transported out in bulk form. This is, as I said before, via the movement of vesicles. So the vesicles in this case is your bag that holds a lot of the material that you want to be transported across the membrane. There are two main types that we talk about. It's called exocytosis and endocytosis. Endocytosis is the movement where substances are taken within the cell. So if you look at the diagram at the bottom, it would be the taking in of substances from outside the cells within the cell. How this works is that your plasma membrane makes an indentation and then it folds upon itself and makes a vesicle. So a vesicle is formed around the material and is transported inside of your cells. For exocytosis, you would have the vesicles already within your cell and they would bind with the cell membrane, your external cell membrane. So it binds to the cell membrane and then the substances are released into the external environment outside of your cell. For exocytosis, there are two types. You have phago and pino. Phago is when you excrete or release solid material, and pinocytosis is when you release liquid material. Both of these processes, endocytosis and exocytosis, requires some form of energy. So ATP is required for this movement to occur. Thank you very much for listening today. I hope you learned a lot. Have a good day. Goodbye.